Question 34. Simplify m over 3t minus 2n over 4p. You have m over 3t minus 2n over 4p. It's just the same thing as subtracting fractions. You find the LCM, then you do the normal process. You rule your line. You might think finding the LCM of 3t and 4p is hard. Just find the LCM of the numbers first. The LCM of 3 and 4 is 12. They have 12. Then since you have one of t and one of p, just join them together, tp. So your LCM is 12tp. That's simple. Now you do the normal process. You divide 12tp by 3t. The answer you get, you multiply it by the numerator, which is m. That's simple. In your rough space, you have 12tp divided by 3t. That's the denominator here. The t cancels the t. You have 3 in 3, 1, 3 in 12, 4. You'll be left with 4p. You have 4p, that's the result, times m is 4pm. And since it's good you arrange in ascending order, you put the m before the p, because m comes before the p as regards the alphabet. So you have 4mp. It's better you put it like this. So if you have like terms, you can easily figure them out and solve. Minus. Then you take 12tp divided by this 4p. Just like you do when you're subtracting normal fractions. So the p cancels the p. 4 in 4, 1. 4 divided by 12, 3. So we'll be left with 3t. 3t. Now we multiply the 3t times the 2n. 3t times 2n. I like this because you have two different letters. 3 times 2 is 6. Then t times n is tn. N comes before t, so you put your n before t. It's still the same thing, 6nt. So write 6nt. Some will jump on this and think it's the final answer. But if you look closely, you will see that there's still something you can bring to the lowest term. This is beyond an average child. This is not the end of it. And looking at the options, you see that this answer is not there. It might seem that you've just gotten it all wrong, but you have not. If this were to be a theory question, and if it were 3 marks, you have gotten 2 out of 3 if you had stopped here. Now, looking at this, you have 4 and you have 6. In both 4 and 6, you have 2. That means you can factorize. They don't have any other thing in common than 2. So you bring out 2. You open a bracket, 4mp divided by 2. 2 in 2, 1. 2 in 4, 2. You'll be left with 2mp. You have 2mp minus. You take this 2 out of this 6. You have 6nt divided by 2. 2 divided by 2, 1. 2 in 6, 3. You'll be left with 3nt. You have 3nt, close bracket, over 12pt. Now, you're taking out 2 out of it. That means you're factorized. If you multiply 2 by both of them, you still get this back. So you've taken out 2. Now, the 2 can cancel the 12. At this point, you can now say 2 in 2, 1, 2 in 12, 6. We can cut to the lowest term. At this upper part, we can't do that. We can't say 4 in 4, 1, 4 in 12, 3. Neither can we say 6 in 6, 1, 6 in 12, 2. It's not allowed in math. You should know this rule. When you have a situation where you have an algebraic expression and another, and they are linked by either subtraction or addition, you can't cancel with what is in the denominator. Even if they were also at the denominator, you can't cancel until you factorize in this way. Then when they are linked by times, like in this case now, this 2 is linked to this algebraic expression by times. It's 2 times what is in the bracket. Then you can cancel. You have to note this. 2 in 2, 1. 2 in 12, 6. So you're left with 1 times 2mp minus 3nt. 1 times anything is that thing. This is now equals to 2mp minus 3nt over 6tp. You still have your tp. This is our final answer. In our options, the answer to this question is D. Where you have 2pm, you can say mp is still the same thing. It's still the same thing when you put the m before the p or the p before the m. Your answer is D. That's 2pm minus 3nt over 6tp.